Thank you so much, first of all, for making the time to attend this technical presentation. As you might already be aware that we'll be talking about high pressure die casting today. So we'll cover basics of what high pressure die casting is, and also discuss the elements that are involved in deciding whether your part is right for high pressure die casting or not. So just to introduce myself, my name is Anisha Raj. I'm the Director of Sales for Exclusive Magnesium. I'm a metallurgist by education. I have 15 years of industry experience. I specialize in something called magnesium alloys. It's a lightweighting alloy, uh, and we are one of the few companies in India which can work with this. Uh, I'm the second generation of a family-run business, and the business itself, which is Exclusive Magnesium, is 28 years old. Started in 1994, I believe. So, as you can see, this is just a slide about our presentation, about our company. As you can see, we have multiple processes. It's not just high pressure die casting that we do. We do sand castings, gravity die castings, machine components, extrusions, forgings. So depending on what the customer has a requirement, we can recommend what the most efficient way of producing their component would be, and we can do it through all these processes. We have capability right from prototyping to serial production. We do components for several quality critical components like for defense, aerospace, drones, electric vehicles, satellite systems, EVs. So we have a lot of, we are sector agnostic in that sense. We exclusively work with magnesium, but also have capability of doing aluminum alloys. We don't actively look for aluminum work, but magnesium is our core expertise. So high pressure die casting is a high production process, volume production process, and it's fairly simple at its as a concept. So as you can see, it's nothing but two metal dies held in position, and molten metal is pressurized into a die cavity and held there till it solidifies. So here you can see a dark gray area of the die. This is called the fixed die in high pressure die casting, and you have a light gray area over here, which is a moving section of the die. So when these two sections are closed, you'd see a small section in between, which is the die cavity, which is the shape of your component. We use molten metal, pour it into a short sleeve over here. There's a plunger which will push that metal with a certain force into this cavity. And when the die, it's held in that position for about 10 seconds to 1 minute, depending on the size of the component. And within 1 minute, they open, you remove the part, and then repeat. So it's fairly simple as a process. And since you're getting one component per minute, you can imagine how many components in a day you would be able to get. So it's usually used for high production, serial production kind of use cases. This is just a picture of how a high pressure die casting machine would look like. Now, high pressure die casting machines range from 60 metric ton to 4,000 metric ton. Now, the size of the machine and what machine size you are using completely depends on your part size. So if you have a larger size part, then you'd go for a higher machine, a higher metric ton machine. And but sometimes even smaller components have to be made in a larger machine. For example, if your component is say about 1.5 mm thickness, wall thickness throughout, and so to push molten metal throughout that 1.5 mm thickness across the part, you need a higher force. And to achieve that higher force of metal push, we would go with a higher tonnage. It depends what machine size your part can be made in, because that would determine the cost of the per shot. So that would depend. That's critical for your part price, and also it's kind of your part price is dependent on that. This is a picture of a high pressure die casting die. So usually high pressure die casting dies are made out of hot die steel, which is H13. As I mentioned before, this is the fixed section of the die. This is the moving section of the die. And when these are closed, that's when the metal is poured in. You can see from this picture that this has two parts. This is a two cavity die. So in a single shot, when the metal is poured in, you'll get two parts in the same shot, right? Usually, the die-castable alloy metals are zinc, aluminium, and magnesium. I also know that lead is also die-casted. We've never done that before, but these are the three metals that we've worked with previously. The industry standard is that a die should give you about 1 lakh shots, which is 100,000 numbers, at least shots at least. In this die, it would be 2 lakh components that would come out. Now, if you make it, but this also is not a hard and fast rule, because if you have a more complex die, for example, this is just a two-piece die. There's only one moving section, but there are dies where there are multiple moving sections from the side and from the top, from the bottom, everywhere. So if you have a more complex die with more complex features, it might reduce the number of shots possible in the die assembly, and that's something to keep in mind. Uh, the last thing in this picture I would want you to notice is that there's a internal insert. If you notice clearly, there's an outer housing, and inside there is where the component is made. It's a different shade of metal. Now, this inside metal is what hot die steel is. So the component is machined out of hot die steel because it can withstand higher temperatures without losing strength, and that's what the hot die steel die is made out of. And the housing can be common, like it can be made out of MS. A lot of customers, a lot of people make it out of different tooling material. So, but usually a lesser price material can be used for housing. The resulting component that you would get is net finish. So as you can see, these are completely finished components that you would get from the high pressure die casting process. They'll be shiny in terms of surface finish. We do something called shot peening, which will give you a shiny finish in the end as well. You can also coat it on top of that. So these are ready for assembly if you need, right? Some of the things that you have to do after die casting, which are holes and critical tolerances. So if you have sections in your part which require something like 50 micron or lesser tolerances, then that is something that will be machined later after the casting process. And the holes always have to be done later in high pressure die casting. The general tolerances that you can expect is 100 micron to 200 micron. So that's what the general tolerances you should expect. Possibilities for high pressure die casting. So the size range that you're looking at is about 5 grams to 7.5 kilos. Now there are some companies in India which have bigger machines which can take almost 11, 14 kilo components as well. Very few, I think one or two. I know Bharat Forge is one of them. So 5 grams to 7.5 is a standard. You would get that anywhere in India easily with any other die caster. The quantities you're expecting in something like this is about, usually the industry standard is actually 2000 units or higher. But we've been working with, we are trying to kind of cut costs in terms of quantity and reduce the cost of die tooling for customers. And we're starting our quantities with 250 units as well. So we work with a lot of these Swedish aftermarket companies which have requirements of only 200 units per year, but the project lasts about 5-6 years. So over a period of time, you would get that kind of quantities which are suitable, and that can kind of justify the die cost. So the die tooling time is actually tooling is actually one of the biggest deterrent for most people. The die is the most expensive part in high pressure die casting. Afterwards, the part cost is actually significantly lower. But the die cost is high, and the timeline. So a small die would take anywhere between 2 months, and a large part die would take a maximum of 6 months. So 2 to 6 months is the usual waiting time. This is something that you have to account for if you're moving to high pressure die casting. The part cost will not be a challenge at all. Usually it's if you're doing machining, then in any other process, if you're making it, then suddenly it'll be like a significant improvement in reduction in price. So price is definitely not going to be the issue. The finish is also not too much allowances for like the other processes. So you don't have to leave machining allowances like in the other processes like sand and gravity. You can get the net finish. So why should you consider high pressure die casting? One of the factors that I already mentioned is the part price, right? So if you're trying to make your part at a cheaper price, then high pressure die casting is something you should explore. The second thing is production lead times. So even though the die will take you about 2 to 6 months, the second the die is ready, you can expect weekly, monthly, kind of even daily production of that die. So we would go from, say, I'll give you examples at a later stage in this presentation, but that's one of those things. Production becomes significantly faster. The next is part consistency. Now, with any other process, you might have some form of variation. Even with machining, you might have variations in tolerances here and there, but with dies, you will